Hi, welcome back. So we are at the last section of this appendix, and that is to have a quick review on the use of TensorFlow. Now, basically, you have to understand TensorFlow is just a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural network in general. As we have seen Python actually as a programming language, we saw lists, for example, as a main pillar, and then we saw NumPy, the concept of the use of an array or NumPy array of 1 dimension, 2 or 3, or even a tensor. And then we saw also a pandas concept of series and data frame. The same thing you have to understand about TensorFlow. What is the structure of their data? So they understand through first something called the tensors. And here, for example, an example of a 2-dimension array. Now, basically, of course, don't forget, you have to import TensorFlow STF. This is the convention, just like we imported NumPy as MP or pandas as PD. To this variable, we assign actually a tensor. In this case, I am passing actually a 2-dimensional array in the form of Python though. Now, if I would have to run this just to show you, you would see that contain the values of 2 dimension. It gives you the shape of it, which is just as a matrix 2 by 3, and give you the type of the element. Also, you can print directly the shape on its own, as we see in a tuple of 2 by 3 or the type. TensorFlow also implements a standard mathematical operation on tensor, as well as many other operations specialized in machine learning. For example, if I would have to run this x plus x, you will get the result can also multiply by a scalar, as we done before. You can also do a transpose operation on the tensor itself. So here's the product of transposing the x and then multiply by that. Also, you get, for example, you can concatenate, you can do a softmax, and softmax is actually a function that known as maybe soft argmaxes, or it is a kind of a normalized exponential function which converts a vector of real numbers into a probability distribution of k possible outcomes. You can use the reduce sum function, etc. So you could see there are a number of built-in functionality within the TensorFlow that you can apply them to the tensor that you have built. Next thing, maybe you need to check something called variables, and basically or normally tensor, tf.tensor, its objects are immutable. So you have to understand, once you see tf.tensor, it's immutable, such as the tuple in Python. However, to store module weights or any other immutable state, because they need to be changed or assigned, in TensorFlow we use a variable. So we get variable and we get tensor. For example, I would have this is a variable, so I can literally assign on that. If this is a tensor, I will get an error if I want to assign to them. So you can see I can use the assign and add to them. Here is the idea of using, for example, automatic differentiation or the gradient descent. So here is an example has been provided where you're getting a variable of 1 is just as one value, and then you define a function that basically is just x squared plus 2x minus 5. If you run this function, basically you will get the result of minus 2. Now the derivative of y, we can use the built-in functionality with TensorFlow called the gradient take. I think the result, if you run, you will get 4 as we expected. You can also use the graph and TensorFlow functionality here. So basically here, for example, by using the decorator tf function, just reduce the sum of the function of x that you pass. You can, of course, follow the instant of this documentation. I'm not going to read for you. However, I just wanted to show you. Next thing, maybe you want to look at a comprehensive example here for a training loop. So that was all about our appendix Python from the start to the end. I hope now by the end of this appendix you have come to understand the syntax or the concept of actually programming language in essential. We have used Python as just an example. However, you can apply the same conceptual understanding from practical perspective and theoretical perspective to any other programming languages. So that was all from me. Thank you very much. Cheers.